All right, so last lesson we talked about finding the real zeros of a function or of a polynomial function. Today we're going to dive a little deeper into that concept and learn how to find both the real and the complex zeros. Now if you think back to complex, a complex number is going to be an imaginary unit, so in the form of a plus bi. And remember, I is the square root of -1. So anytime you have the square root of a negative number, that becomes the I. So let's take a look at this. Here is our function here. And the equation to this graph is the polynomial function f of x equals x to the third plus x squared minus 3x minus 6. So that would be given to you. The function is given to you. In last lesson, we talked about the highest exponent, or the degree of the polynomial, is the number of zeros that this could have. So this indicates that this has at most three zeros. So no more than 3. Okay, so if we're using this function and we're trying to find all the zeros, the first thing we want to do is graph it. So here it's graphed for us already, but if you didn't have that graph, you would plug that into your graphing calculator or into Desmos, and you would find that it has the x-intercept of +2 there. So that is our first real zero. X equals 2 would be our real zero. But this polynomial can have other imaginary or complex zeros. So we need to find those as well. So we're going to start with our real zero of 2 here. And then we're going to use synthetic division to find the rest of the zeros. So here's your success criteria. So step 1, use the graph, so graph it, and then determine one of the zeros. You only need one to start. And we found it's x equals 2. And the way you confirm it's a zero is when you plug it into synthetic division, you should get a remainder of 0. So let's try that. So we're going to use our 2 here for our divisor, and then our coefficients are 1, 1, -3, -6. And then we'll start our process of synthetic division. Start by bringing down the 1, multiply 2 times 1 is 2, add 1 plus 2 is 3. Multiply 2 times 3 is 6, add -3 plus 6 is 3. Multiply 2 times 3 is 6, -6 plus 6 is 0. That 0 remainder tells us that this is in fact a 0. This is a factor of the polynomial. Now we can write this in factored form. So after you use the synthetic division, you're going to write in factored form. Okay, so factored form is divisor times quotient. So our divisor is x minus 2. Remember, if you start with x equals 2, to get it in factored form, you would have to subtract it to the other side. So divisor, x minus 2, And then quotient would be this right here. So we started with x to the third, so you're going to go down 1. So x squared, x, and then that plus 3. X squared plus 3x plus 3. Okay. Now, we have one factor. We need to find the other zeros by factoring this polynomial here. However, x squared plus 3x plus 3 cannot be factored. There's no factors of 3 that add to 3. You only have 1 times 3 here, and 1 plus 3 is 4, so that doesn't work. So this is not factorable. So in this case, when you come across a problem that can't be factored, you have to use the quadratic formula to find the rest of the zeros. So quadratic formula is when the quotient cannot be factored. Okay, so let's look at this. So let's review quadratic formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. And then let's determine our a, b, and c. So our a is 1, our b is 3, and our c is also 3. Now we're going to plug it in here. Negative b, so negative 3, plus or minus square root b squared, 3 squared, minus 4 times a times c over 2a. All right, it's all set up. Now we're ready to simplify it. So negative 3 plus or minus 3 squared is 9. Negative 4 times 1 times 3 is negative 12. All over 2 times 1 is 2. 9 minus 12 is negative 3. And that's as far as we can take it. But we need to remember that when you're taking the square root of a negative number, it becomes the imaginary unit I. So I need to rewrite this as negative 3 plus or minus the square root of 3 becomes positive I, all over 2. You could also see it like this. This is also acceptable when the i's in front of the 3. Either form is fine. Okay, so let's put all the zeros together. So my real 0 was 2, and then here are my complex zeros. So this actually stands as 2 zeros. So you have negative 3 plus I square root of 3 over 2, and you also have negative 3 minus I square root of 3 over 2. So these are the complex because of the unit I, and this one is the real. So final answer. The zeros are x equals 2, x equals negative 3 plus square root of 3I over 2, and x equals negative 3 minus square root of 3I over 2. All right, so that's our first example. We're going to do one more example. So I want you to go ahead, pause the video, and try it on your own, and then we'll go through it together. Okay, so we're looking at try it number 3A. So step 1 is to find your 0. Oh, didn't give you the formula there. You need that. Sorry about that. probably wondering, what in the world, how do I even start? Okay, this should be given to you. Without your equation, you can't find the zeros. So now pause the video and try it on your own. Sorry about that. Okay, so we would start by plugging this into our graphing technology, and we would find the graph looks like this. And then you see your first zero is here at x equals 3, and that's your real zero. So we find that the real zero is x equals 3. So now we take our real zero, 3, and that becomes our divisor for the given polynomial. So we use our leading coefficients here, so 2, -8, 9, and -9. And then we're going to use synthetic division. So you start by bringing down that first term, 2, then you multiply, add, multiply, add, multiply, add. Remember, you should always get a 0 remainder here after you plug in that first 0. If you don't, something went wrong. Go check your work. Okay, so the factored form is x minus 3 coming from the divisor, and then 2x squared minus 2x plus 3. So now we're going to take this quotient here and we're going to see if we can factor it. So are there any factors of 3 that add to -2? No, there are not. So unfortunately we can't factor, so we have to use the quadratic formula. So our A is 2, our B is -2, and our C is 3. And then we'll use those values and plug it in to our quadratic formula. So -b plus or minus square root b squared minus 4ac over 2a. Okay. Then we're going to simplify. Negative makes a positive. -2 squared is positive 4. That's like saying -2 times -2. And then -4 times 2 times 3 is -24. All over 2 times 2 is 4. Then you have 2 plus or minus square root 4 minus 24 is -20. All over 4. You cannot have the square root of a negative, so this becomes the imaginary unit of the square root of 20. Now, you can simplify square root of 20, and you have to do that. So let's pull that to the side. Square root of 20. How do you simplify a square root? Well, you need to make a factor tree. So 4 times 5, and then 4 breaks down to 2 times 2. Circle your pairs. Pairs go outside. The singles stay inside. So the square root of 20 simplifies to 2 square root 5. So now I can write my answer, my final answer. So my zeros are 2 plus I, oops, that's a 2 there, sorry, 2I square root of 5 over 2. Now, actually, you can simplify that even more, and we really should, because you can reduce that by 2 there. So this is really 1 plus I square root of 5, plus or minus. Okay, now we can write our zeros. So our real zeros was x equals 3, and then we have x equals 1 plus I square root 5, and x equals 1 minus I square root 5. And then those would be all your zeros there.